Hey guys, welcome to brainAttic. So today we have another very interesting problem from the topic of limits. Now this question was not asked in any JE but is a potential problem which can be solved. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So here, let us say that In is equal to integral over 0 to 1 x power n 1 plus x dx. Now what we are going to do, we are going to substitute x with 1 minus of t by n. So once we do this, what is dx? Dx is nothing but minus dt by n. So upon substitution, our limits will also change. So when x is equal to 0, t becomes n. And when x is equal to 1, t becomes 0. So now my new integral in, in was basically integral over 0 to 1 x power n by 1 plus x dx. Now this integral will change and become n integral over t is equal to n to 0 1 minus of t by n power n by 1 plus 1 minus of t by n dt by n, and there's a negative sign. Okay, so this n and this n gets cancelled. You're getting the intention of using this term, right? So what we have now, this minus negative sign will interchange the limits and we will have the limits from 0 to n, and our integral will look 1 minus t by n power n 2 minus t by n dt. So this is my fresh integral. Now for each fixed t greater than equal to 0, we have to check. So our intention now is to bring this limit inside the integral. Okay, so there are two things for that. What we know is the dominated convergence theorem. So anytime if you have a limit and then an integral and you want to change it to integral and the limit inside, right, then you have to apply this dominated convergence theorem. Now there are 2 points to it which you have to be careful. First thing is that this theorem only applies when there is a pointwise convergence. I'll show you what it means, pointwise convergence. And second thing is that the domination by integral function. So what does that mean? Is that if your limit is applied to this region, the integral must be applied to this bigger region. Okay, so the limit must be applied to this bigger region. Only then you can actually apply the dominated convergence theorem. So what we are going to do is that for each fixed t greater than equal to 0, we are going to check whether it is pointwise convergent or not. Okay, so we see that for each fixed t greater than equal to 0, we see that limit n tends to infinity 1 minus t by n power n is equal to minus t. This is a regular limit, we know that, and limit n tends to infinity 2 minus t by n. As n tends to infinity, this term will go to 0, so we are left with 2. So we have that the integrand converges pointwise to e power minus t by 2. So we have found that out. Now similarly, if you check whether the integral range is greater than the limit range, right, you will very easily inspect and identify that it will be something like this. My bad. 2 minus t by n less than e by minus 2. So definitely the integral range is greater than the limit range, so we can easily apply. So the function, basically this is what I'm trying to say, is that this is integrable over 0 to infinity completely. So what we have now is limit n tends to infinity in, which is equal to 0 to infinity e power minus t. So I'll take the half out, and then I have 0 to infinity e power minus t dt, which is basically 1. So the answer is 1. If you do like the video, subscribe to our channel for more content like this. Thank you so much for watching.